Hello everyone. This is Sridhar Reddy Bijula, Assistant Professor in Mathematics, Laxman Institute of Technology and Management. The subject name is DEVC, means Differential Equations and Vector Calculus. So the topic name will be Ordinary Differential Equations of Higher Order. This is today's topic. So next. What is the meaning of higher order differential equations? In general, we will discuss the nth order linear differential equations. So, what is the nth order and what is the general form of the nth order linear differential equations? See here, an nth order the nth order differential equation of the form d power n y by dx power n plus p1 of x into d power n minus 1 y by dx power n minus 1 plus p2 of x into d power n minus 2 y by dx power n minus 2 plus so on dash plus pn of x into y equals to q of x. This is called nth order linear differential equation with variable coefficients, because here the coefficients are p1 of x, p2 of x, p3 of x, so on, pn of x. These are the coefficients that contain the variables x. So these are the variable coefficients. If the coefficients p1 of x, p2 of x, p3 of x, if they are the numbers, then we can call it as with the constant coefficients. That means in the next one, an nth order differential equation of the form d power n y by dx power n plus a1 into d power n minus 1 y by dx power n minus 1 plus a2 into d power n minus 2 y by dx power n minus 2 plus so on dash plus an into y equals to q of x. This is called nth order linear differential equation with constant coefficients. Because here a1, a2, a3, so on dash an. All these are called a1, a2, a3, so on dash an. All these are called constants. All these are constants. So the differential equations, this is called nth order linear differential equation with constant coefficients. So what is the purpose and why we need to study this differential equations? In mathematical approach, we need to study to solve these differential equations. We need to solve these linear differential equations. So how to solve these linear differential equations? Means here, the solution for higher order ordinary differential equation. So for this type of differential equations, the general solution will be that contains y equals to CF plus PI. Yes, CF and PI. This is CF is a complementary function. Complementary function. And PI will be the particular integral. PI will be the particular integral. So here you can see this, the differential equation in the equals to. For the equals, the left hand side part will be this. For the left hand side part, we need to find the solution. The solution is called complementary function. And the right hand side part, that is the q of x, is also called some input function. For this input function, we need to find one more solution. The solution is called particular integral. In this session, now we need to discuss how to find the complementary function. Let's discuss the how to find complementary function for the higher order linear differential equation. Right. So here, the solution for the higher order linear differential equation will be So y equals to complementary function plus particular integral. That you can write y equals cf plus pi. And that also you can write y equals to yc plus yp, symbolic notation. So how to start? How to start and how to find a complementary function. So first of all, let us consider the differential equation. Differential operator. Let's take the capital D means d by dx. That will be the differential operator. Then d square can writing as d square by dx square. Second order differential operator. Similarly, d cube means d cube by dx cube. Third order differential equation. So on continuation, d power n that can writing as d power n by dx power n. This is the nth order differential operator. We need to replace these derivatives with the differential operator in the given differential equation. And then rewrite the given differential equation into operator and symbolic form for the given differential equation. So using these values in equation 1, we get d power ny plus a1 into d power n minus 1 into y plus so on as plus an into y equals to q of x. So here the derivatives are replacing by respective differential operators. From here all, you can take y common. Then after taking the y common, we get d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus so on as plus an into y equals to q of x. Right. So this can be considered as f of d. F of d into y equals to q of x. So writing like this is a called symbolic form. Right? So whereas f of d that will be the d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus a3 into d power n minus 3 plus so on as plus an. This is a mathematical expression in d of degree n. Right? After rewriting into symbolic form and identifying the mathematical expression in d of n, then what the next step? So after getting the f of d value, there is a d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus so on as plus an. This is a mathematical expression in d of n. Now, from this, we need to take the auxiliary equation. Auxiliary that be f of m equals to 0. By using this mathematical expression, we need to take the auxiliary equation that will be f of m equals to 0. That means from this we can write m power n plus a1 into m power n minus n plus a2 into m power n minus 2 plus so on as plus an equals to 0. This becomes an algebraic equation of degree n. Now solving this equation, we get n roots. Solving this equation, we get n roots. The roots may be real numbers or complex numbers. Now let's discuss how to find the complementary function based on the roots we get. Right. So we are considering auxiliary equation f of m equals to 0. Done. So the equation will be this, which is an nth degree polynomial equation. Hence, it has n roots. Now let us consider n roots of equation f of m equals to 0 are m1, comma, m2, comma, m3, comma, so on as mn. These roots may be real numbers or may be complex numbers. Maybe complex numbers. So based on this, we need to construct the complementary function. Let's say what is the working rule. So based on this type of roots, the complementary functions are defined as mentioned below. Let's how to define the complementary functions. The first one. The roots are m1, comma, m2, comma, m3, comma, so on, mn are real and distinct roots. If the roots are real numbers and they are distinct, then we can write the complementary function like this. Yc, that is also called complementary function, CF. That you can construct for the m1, you can write the complementary function like c1 into e power of m1x is the first root. For the second root, m2, you can write c2 plus e power of m2x plus for the third root, m3, you can write c3 into e power of m3x plus keep on continuing. For the nth root, mn, you can write cn into e power of mn into x. So this is the way we can construct the complementary function whenever the roots are real numbers and they are distinct. Next, if the root is repeated, then we can construct like this. Here m1 equal to m2 equal to m3 equals so on. The roots will be m. Right? So m1 value, m2 value, m3 value. That will be equal roots. Then we can construct the complementary function like this. c1 plus c2x plus c3 x square into e power of mx. And the remaining roots are writing the same way. Right? Next, if the roots are complex numbers, if the root alpha plus r minus I beta, the roots may be, you may get like alpha plus r minus I beta. This will be a complex root. Whereas alpha will be the real part and beta will be the imaginary part of the complex root. So whenever you are getting the complex roots, then how can you write the complementary function? So suppose if the root will be alpha plus r minus I beta, then you can construct the complementary function like e power of alpha x into c1 cos beta x plus c2 sin beta x for the complex root alpha plus r minus I beta. And the remaining roots can write in the same way. Okay. So these are the same procedure. We can follow this. Now let's start with one example. Right. This here I'm going to take one example. So here you can observe the right side, that will be the 0. So for the function 0, nothing to find. So here you no need to find the particular integral for the differential equation. Just you need to calculate for the left hand side part solution, that means complementary function. So here just we need to find the complementary function. No need to find particular integral. Right. So what is the differential equation here? D square minus 4d plus 3 into y equals to 0. So given differential equation is already in the operator form. That maybe sometimes they give in the differential like this. d square y by dx square minus 4 into dy by dx plus 3 into y equals to 0. Sometimes we may get like this, the derivatives. We already know you can use the differential operator d by dx. So d you can write d by dx and d square you can write d square by dx square. So here you can replace in the d square by dx square by d square y and minus 4 into dy by dx. Here you can replace with dy plus 3 into y equals 0. So from the 3 terms you can take y common, then we'll get d square minus 4d plus 3 into y equals to 0. If the differential equation given like this, you need to rewrite into this operator form. Right? After writing into the operator form, then we need to start finding the solution. Okay. So here the given differential equation will be, okay, solution. Here the given differential equation, that is d square minus 4d plus 3 into y equals to 0. Okay, right. Now here I am writing this, the notation f of d into y equals to 0. First of all, we can take this equation 1. I am comparing this, whereas f of d equals to what? That is the d square minus 4d plus 3. Right? Next, take the auxiliary equation, that is f of m equals to 0. That means m square minus 4m plus 3 equals to 0. Here you can observe this is the quadratic equation in m. That is second degree algebraic equation. Now we need to solve using whatever the methods you know. So here you can solve this using, right, suppose a x square plus bx plus c equals to 0. This is an algebraic equation. Then what are the roots for this? X equals to minus b plus or minus square root of b square minus 4ac by 2a. This is a formula. So here in place of x, here we have m. Right? Next. So using this formula, how to solve this? Minus of minus 4 plus or minus square root of minus 4 whole square minus 4 into 1 into 3 by 2 into 1. Then minus or minus plus or minus square root of 16 minus 12 by 2. And this equals to 4 plus or minus 16 minus 12 means 4. Square root of 4 means 2 by 2. Next, 4 plus or minus 2 by 2. That is, either you may get 6 by 2 or 2 by 2. Then you will get the roots 3 or 1. So therefore you get the roots that equals to 1 comma 3. And here you can observe both the numbers are real numbers and both are distinct. Both the numbers are distinct. So then how to write the complementary function CF, that also called YC? Just go back. So here you can observe M1 comma M2 comma M3 comma so on as Mn are real and distinct. But here we have only 2 roots. Why? Because our differential equation is second order differential equation. So here we got only 2 roots. Right? So and the 2 roots both the 2 roots are real numbers and distinct. Then how to write CF? Then you can write C1 into e power of 1 into x plus for the second root 3. How to write the complementary function? C2 into e power of 3x. That's it. This is our required complementary function and also called solution for the given differential equation is the required solution. And where C1 and C2 both are arbitrary constants. Both will be arbitrary constants. Okay. Similarly, one more example. Now this. And this is also a second order differential equation. Now let's see how to start this differential equation. Solution. Given differential equation, d square minus 2d plus 1 into y equals to 0. Take number 1. Next, this here I am writing f of d into y equals to 0. Comparing with that, where f of d equals to that d square minus 2d plus 1. And next, take the auxiliary equation f of m equals to 0. Therefore, m square minus 2m plus 1 equals to 0. We observe that this is again a quadratic equation. Now solving this quadratic equation, we get the roots. So on solving this quadratic equation, we get the roots, and the roots will be 1 comma 1. Here you can observe the roots are real numbers, but repeated. So the first root m1 value and second root m2 value, both the values are 1. So therefore, the roots are real and repeated. In this case, we can write the complementary function CF is yc equals to c1 plus c2 x into e to the power of x. This is the required solution. Is the required solution. Whereas C1 and C2 are arbitrary constants. C1 and C2 are arbitrary constants. Okay, let's discuss one more example. So solve the differential equation d square plus d plus 1 into y equals to 0. So here the given differential equation solution. Given differential equation d square plus d plus 1 into y equals to 0. Take number 1. Then you can write the symbolic form, that is f of d into y equals to 0. Whereas f of d is d square plus d plus 1. Now take the auxiliary equation AE. That will be f of m equals to 0. F of m equals 0. So here f of m means m square plus m plus 1 equals to 0. Again, this will be the quadratic equation. Now solving this quadratic equation, we get the roots. Whatever the methods you know, use the methods and solve the equation. Here I can use the formula again. M equals to minus 1 plus or minus square root of 1 square minus 4 into 1 into 1 by 2 into 1. This equals to minus 1 plus or minus square root of 1 minus 4 by 2. This equals minus 1 plus or minus square root of minus 3 by 2. Here you can observe minus 1 plus or minus square root of minus. The square root of minus means that will be the I. That means imaginary number. And into square root of 3 by 2. You can rewrite this minus 1 by 2 plus or minus I into root 3 by 2. This means which is a complex root. This is a complex root. And in the form of alpha plus or minus I beta. Comparing with this, alpha equals to minus 1 by 2, beta equals to root 3 by 2. So we get, whenever we get the complex roots, then how to write the complementary function? Let's go back to this. Here you can see the root m1 equals to alpha plus I beta and m2 equals to alpha minus I beta. Okay. Then the root n will be alpha plus I beta or alpha minus I beta. That will be a complex root. In this case, you can write the complementary function like this. E to the power of alpha x into c1 cos beta x. So here, we can write the complementary function yc equals to e power of alpha means minus 1 by 2 into x into c1 cos beta means root 3 by 2 into x plus c2 into sine root 3 by 2 into x. This is our required solution. Is the required solution. Whereas C1 and C2 are arbitrary constants. C1 and C2 are arbitrary constants. Those C1 and C2 arbitrary constants, those will be discussed in later sections.